Today we're working on exponents and multiplication, so title your notes. And then let's take a look at the first example here. It tells us to answer using exponents. So we have 2 to the third times 2 to the fourth power. Normally you could just type this in your calculator and get a numerical answer. However, they want us to answer this problem with exponents. So let's talk about what this really means first of all. We have 2 to the third power, which means you are taking the number 2 and multiplying it by itself 3 times. 1, 2, 3. Then we're multiplying that by 2 to the fourth power. Well, what does that really mean? 2 times itself 4 times. 1, 2, 3, 4. So here I color-coded everything so you could see the difference. So we've got 2 to the third power, which is 2 times 2 times 2, and 2 to the fourth power, which is 2 times 2 times 2 times 2. Now if we were to combine all this together, what do we really have? Well, we've got 2's, which could be our base, and how many times are we multiplying the 2 times itself? Well, count them all up because they're all 2's, so I can just combine it into 1. So this would be 1, 2, 3, 4, 5, 6, 7. Therefore, my answer would be 2 to the 7th power because I'm multiplying 2 by itself 7 times. All right, let's look at an example like this using variables. A to the 6th times a squared. Well, what does that really mean? It means we're taking a and multiplying it by itself 6 times. Then we're multiplying that times a times itself 2 times, which is what I did here, and I color-coded it again so you could see. We have 1, 2, 3, 4, 5, 6 a's here, and then 1, 2 a's here, all being multiplied. So then when you go to get your answer, you want to just count up how many total a's you have. So our base would be a, and then how many a's are being multiplied? 1, 2, 3, 4, 5, 6, 7, 8. So my answer would be a to the 8th power. So now if you've figured out the rule here, there is a shortcut. Instead of writing out all the a's or writing out all the 2's or whatever the base is, you can add the exponents. So make sure you write this whole slide in your notes. When you are multiplying powers with the same base, you add the exponents. Now let me go back to the examples we just did to make sure you're really understanding this. So here we multiply 2 to the third times 2 to the fourth power. We don't have to waste our time and do all this. What we can do is we notice that we have the same base. Both of our bases are 2, so the base will stay the same. Since the base is the same and I'm multiplying these 2, all I have to do is add the exponents. So 3 plus 4 is 7, which is what we got anyways, but it's just a faster way of doing it. Okay, let's look at the next example we did. A to the 6th times a squared. Again, our base is the same, a, so I keep that the same. Now I just add the exponents, 6 plus 2, and I get 8. Again, same answer, just a faster way of doing it. So again, make sure this is the same slide as before, but make sure you have that written in your notes that to multiply numbers or variables with the same base, you add the exponents. All right, now what happens if we don't just have the same base with the exponent? As you can see here, we have x squared times x to the 5th. Okay, we could all do that. I've taught you how to do that. However, now we've got coefficients added in. We've got a -2 and a -3. So let me break this down again so you could see. What we really have is -2 times 3. Then we've got x squared, which would be x times x. And then we've got x to the 5th, which is x times itself 5 times 1, 2, 3, 4, 5. So when I'm solving this, what I want to do is multiply that -2 times 3, which would be -6. And then I want to count up all my x's. So it's x to the 7th power. Again, you don't have to count them all out. You could just add 2 plus 5 and you would get 7. So our answer here would be -6x to the 7th power. The reason why I included this one is because what happens is people, they look at this problem and they're so used to adding the exponents, x squared and then x to the 5th. They get x to the 7th. Most people get that correct. But what happens is they start adding the -2 and the 3. No. The -2 times 3 is still being multiplied. Okay, so -2 times 3 would be -6. So be careful with that. You're multiplying the numbers, the coefficients. It's only when it comes to the exponents that you're going to add them. All right, now let's look at something completely different, which is called finding power of a power. So you might even want to draw a line in your notes to separate this next section because this is different. Remember, a power is, just to refresh your memory, if we have like x to the 4th power, this whole thing is the power. Remember that x is the base, 4 is the exponent, but the whole thing is a power. X to the 4th is the power. So now we're taking that power and raising it to another power, and let me show you what that looks like. So the way you would say this is 2 to the 3rd power to the 4th power. We're taking this power right here and raising it again to another power of 4. So let's talk about what this really means. So if we have 2 to the 3rd power, that's our base right now, okay, 2 to the 3rd. And what we're doing is we are multiplying it by itself 4 times. Think about what an exponent means. It means you're taking this quantity and multiplying it by itself 4 times. So 2 to the 3rd times 2 to the 3rd times 2 to the 3rd times 2 to the 3rd, 4 times, which is what I put right here. Now you know how to do this because this is the same thing we did in the last part. If you are multiplying powers with the same base, they all have a base of 2, all you do is add the exponents. So your base stays the same, which is a 2, and then you add 3 plus 3 plus 3 plus 3, and you get 2 to the 12th power. Do you see the pattern yet? What can we do here instead of having to write all this out? Well, in case you didn't catch it, when you're finding power of a power, it says to find a power of a power, you multiply the exponents. Again, make sure you have that written down. This is different than what we wrote down before. So let me go back to the example that we just did. We were doing 2 to the 3rd to the 4th. You don't have to write all this down. You see that your base is 2, so you keep your base the same. And now you have power of a power, so you want to multiply 3 times 4, and that's how you get 12. You could do it this way if that's easier for you, but this is just a shortcut that you just multiply the exponents. All right, now I want to talk about the difference between what we did today. This is the first thing we did with just the multiplication. And then down here we've got the second thing on the slide is power of a power. Because people get confused as to when you should add the exponents and when you should multiply the exponents. So let's talk about the difference between these two problems here. Because as you can see in this one, I added the exponents. 3 plus 4 was 7, and in this one we multiplied. 3 times 4 is 12. Very different answers, so you've got to know when to do which one. Okay, so in the problem on the top, be careful. People tell me all the time, well, this one has parentheses, so I'm just going to look for the parentheses and I know that I should multiply. That's not always reliable because remember, you could also write this problem like this. So don't just look for parentheses. What you want to look for is the number of bases. How many bases do I have on the top? 1, 2. Remember that big number is the base, so 1, 2. How many bases do we have on the problem on the bottom? Only 1. So when you have 2 bases and you're multiplying the exponents, you're multiplying the powers, I should say, you want to add the exponents. When you only have 1 base, and this is called power of a power, that's when you want to multiply the exponents. Okay, so I just want to make sure you saw the difference between those two. Otherwise, that's it for today, guys. Bye-bye.